Thank you very much. It's a pleasure to be here. My name is Or Weis. I'm an Intelligence Core alumni coming to you directly from Tel Aviv, Israel. I was also a VP of R&D in a cybersecurity company, and most recently I co-founded developer tools companies. One is Rookout, and more recently Authorizon, which deals with building full stack authorizations for your products. Naturally, I'm going to talk about authorization and permissions, and specifically about them in your cloud, in how you're building them into the products that you want to deliver in your cloud native solutions that you're tailoring for your end customers. So first of all, authorization is hard. It has always been hard, but it's getting harder as things are becoming more complex. Back in the day, you know, everyone, when you speak to a developer, they will always say, oh, I've built authorization or access control for my products tens of thousands of times. It used to be very simple. You could use something like, if you're in Python, you could take like Django, or in Java, you could take Spring Framework, and there would come some built-in administration and access control. But those are no longer applicable in the cloud native space, as your application kind of explodes into microservices and becomes more distributed. You end up replicating a lot of the components there. But still, everyone starts with, I'll have admins and not. And from that point, it's actually really hard to see where the game is moving forward. So before we kind of look in a kind of more holistic sense about the problem, let's think about the different elements that exist there that actually make it more complicated. So I already kind of touched on infrastructure. Applications today, as opposed to before, are not monoliths, they're microservices, and they're highly distributed. They might also have devices or instances that are deployed at the edge, and we need to control access to those as well, or how they tailor access to them. Third-party services. When we're building applications today, it's no longer just our code or some open source code we bake in. We're actually working with a lot of third-party services. Think about how you do billing today with something like Stripe, how you do authentication with something like Auth0, and how you do your databases and your analytics, et cetera, et cetera, et cetera. And you need to gate access to those elements in the applications just as much as you have to your own microservices. So that's already complex, and again, becoming constantly more complex. The other part is the policies. The way we enforce permissions ourselves is also getting very complicated. We used to just be able to do simple RBAC, but now with applications becoming more dynamic, more distributed, we need more complex models. Where are users connecting from? What part of the department do they belong to? What time are they connecting? Are all elements that we need to start baking into our authorization. So as I said before, everyone starts with admin or not admin, but quickly that can spin out of control, and you need a completely different policy, a completely different set of permissions or model to work with that. And because of those distributed data sources that we have, third party that we also have multiple data sources. Let's say we want to enable a policy like this. Only users that have paid for a feature should be able to use it. We need to sync with a distributed remote data source. We need to sync with the service, something like Stripe or Chargeify, where we have that information. And the rules themselves are obviously getting more complex. And lastly, the demands of the organization itself. Security and compliance are also becoming more complicated. Security is on the rise. This meetup is sponsored by Palo Alto, so that's should be kind of clear. But compliance is also increasing. The friction around privacy, when you have things like GDPR and CCPA, now you're not only managing who should access the data, but also how are you propagating the data between the different services. So that's another critical aspect of access control that you need to bake into your products. So I think it's easy to say that this is hard, and it's, again, becoming harder. So what are we supposed to do about this? So the main thing that we can take here is we can't stick to the ways we worked before. We need a new way of thinking. We can no longer go and build authorization as an afterthought. It's not just like, oh, I'll have an admin and maybe another role. It's going to change dynamically. I'm going to face more compliance, more security demands, more demands from my customers. I'll need more complex policies. And if I don't plan for that in advance, when the problem actually arrives, when the shit hits the fan, it's going to be painful. So we need to plan for this in advance. In addition, it's continuous. Authorization is not something that we just solve once and we're done. It's evolving, it's changing as our product is evolving. And in the end of the day, we need to realize that this is critical for the end experiences that we're delivering to our customers. How people connect to our product is essentially the doorway to our product. And if the entrance is hard, we'll end up losing users. And lastly, we need to understand that authorization is part of a bigger space, IAM, Identity Access Management. So we need authorization to connect to both our authentication and upstream to our identity management, or more correctly, to our customers' identity management. So now I'm going to take you through some best practices on how you can think about solving this problem next time you're building your authorization or access control to your product, or next time you're upgrading your product. If you follow these 5 best practices that I'm going to list, you'll save a lot of pain down the road. You'll essentially be making your product, your cloud-native product, future-proof to a significant degree. Nothing is completely future-proof, but it will be significantly future-proof. And that way you'll, well, just save a lot of pain for yourself. So probably the most important best practice that is also becoming kind of a trend, is also being led by the CNCF itself. It's kind of its principles that it's bringing to the cloud-native space, is decoupling policy and code. The most kind of naive approach that we have is to bake in access control code or policies into our product. So let's say we have an API or another kind of route in our application. We start handling it, and we just write more code at that point that checks if the user or entity that is approaching that route should be able to use it. And then we have the code for the application itself, the logic for the application, kind of mangled together with the code for the authorization layer. That's a really bad idea, because once we do that and we start replicating the authorization code between different microservices, when we need to upgrade it, as we saw that we'll probably need, or when we need to add more capabilities to it, or when we need to better monitor it, we won't be able to, because we need to fix a lot of different areas of code, and those will also end up drifting from one another. So we want to decouple our policy from our code. We want to have essentially a microservice for authorization, a separate service where just the logic for authorization will sit there, and the other microservices will use it to achieve their goal of authorization. So that's the first best practice, and probably the most important one. If you take anything from my talk today, please take that best practice. Secondly is being event-driven with how we do authorization. So when you're building an application, things are dynamic within it. People can invite new users on the fly. They can assign new roles on the fly. They can connect or change the things in those third-party services that we mentioned. For example, swiping a credit card. If we have everything managed in a non-real-time fashion, not have it event-driven, we'll have a hard time syncing and getting the data that we need to make authorization decisions. So from the get-go, we should design our authorization layer to be event-driven, meaning every time there's an event that can change authorization, we would want to propagate that through the system to make sure our authorization layer learns about it and is in sync with what's happening in the application and those third-party data services that we might be working with. This is essentially also a way to how we can go and not only decouple policy and code, but also decouple data from code. The data that we need for authorization is not the same data that we need for the application itself. It might overlap, but it's not necessarily the same, and we should focus on having it pair the need for the authorization layer. The third best practice is to be aware of what we end up catering with our authorization layer. So we're not just building authorization to enforce and check what's going on. It's going to be a part of the product. And with companies that are building products, companies that are product focused, in the end of the day, this affects not just the developers, but also the DevOps people and the product managers, and security and compliance, and a lot of different stakeholders, also sales and marketing. Everyone needs to be able to connect to the access control experience, because as I said before, it's the doorway into your product. So if you can't manage that product, you end up having a bad time. So we want to plan in advance to give controls and interfaces through a back office to the different stakeholders that we have. So we need to, at the get-go, think what kind of interfaces and what different stakeholders would need from the access control to our product. In a similar sense, our fourth best practice talks about our end customers, our end users. So it's not just us managing the product, but also the people working within the product. We want them to be able to have their own audit logs, for example, within their tenant. They should be able to see what they've done within the product. That's something that almost every B2B application user would ask. So we can kind of realize that too late, but if we follow this best practice, we can recognize it in advance and plan for it and build an authorization layer to be able to latch on different interfaces to cater to the different people that end up using the product. In best practice 3, that would be the inside users. In 4, that will be the end users themselves that also need control. And lastly, GitOps. So we've essentially created a separate microservice for managing authorization. We are able to, in an event-driven fashion, deliver updates to it. And so now the best way to kind of go about managing it, applying versions to it, applying additional checks and balances, making sure that the code for that microservice and the data for that microservice complies with our demands and our requirements is GitOps. So we essentially create a pull request for every version change. We connect that to the data pipeline. And then our developers, as they are upgrading the product and its access control, can essentially just push a new commit with new code, have that go through the tests and checks, and then have that applied to the overall authorization layer. So these are, as I said before, the best practices, and we need to see how we can combine all of them together to get our product to be as future-proof as possible for authorization. So now that we know what are our goals, essentially, what we want to have in our authorization layer, now let's talk a bit about some open source options and integrations that we can apply to achieve that easily. First of all, before we talk about the solutions themselves, let's talk about the overall ecosystem. So as I said before, authorization is part of the IAM space. And there we want to use open source standards to connect up the funnel. So, and the most important one in this case is JWTs, or JSON Web Tokens. Essentially, JSON documents that are signed cryptographically by the authentication layer. And we can use that to recognize what is the entity we're applying authorization to. And through the authentication layer, through XAML and Open Connector, we can connect to the identity management on the customer side, and through that get additional information about the entity. For example, where they are on the world, which department do they belong to, et cetera, et cetera. So that information will propagate as claims into the authentication layer. And through the JWT, through the JSON Web Token, we can have that propagate into the authorization layer that we're building. It's really important to use those best practices so we'll be able to switch out and use different solutions for both authentication and identity management without having to refactor the entire product. So now we have an identity. We are connected with a user within our code. We have a separate microservice that we're building that will apply authorization based on that identity or based on that JSON Web Token. So now we need a good way to write code for that authorization microservice, have it focused on authorization exclusively, and have it be easily managed by GitOps, as we mentioned before. So there are two main camps today in the market that are bringing engines for building authorization as open source that we can bake into our products. The idea here is that we can obviously go and build a proprietary microservice for authorization, but by using the open source projects, we can save a lot of work, obviously, but also avoid a lot of classic mistakes. There are two camps, as I started to say. The first one is code policy agents. Essentially, a service or agent that can be loaded with dynamic code and have that code then answer queries on authorization. So we have in most cases, a unique language that we can use to write authorization flows. And we have a pre-made service that we can load that language into. We can also load additional data. And then we can ask it things like, does this user have the ability to use this feature? A few leading examples for open source solutions here are Open Policy Agent, which is part of the CNCF, OSO, and Caspin. Open Policy Agent is probably the most important engine in this category at the moment. It also has the biggest community and biggest traction. It's a graduated project as part of the CNCF, meaning it's on par in maturity with Kubernetes. And if you're looking where to start on where you can get your policy agent, that's probably the first place you should look at. The other camp, the other option is permission-based graphs. The kind of mindset leader there is Google Zanzibar. So Google released a white paper on how they do authorization for things like YouTube and Google Drive. In the end of the day, it's basically managing a huge graph that creates a relationship or tracks the relationships for the different entities in your application. The advantages of using that graph is that it can manage a lot of data, and you can have a whole picture, and you can have what's called reverse indexing. You can say, not only does this user have access to this feature, you can also ask the reverse, which users have access to this feature? But on the other hand, it's far more complex. It's much harder to make distributed, and it often comes with network latency because we're managing a separate huge service that is far away from our each microservice that we're managing. On the other hand, OPA or other policy agents have the advantage of being very lightweight, having the advantage of being closer to the end microservice that needs their capabilities. So they'll be more performant and there will be less network latency. And it's also, we have more ability to express ourselves because in the end of the day, we're writing code. So it's essentially Turing complete. Well, with a graph, as if we want to stick to a graph that will be stable to maintain, we can't really go too crazy here. So these have pros and cons, and according to what type of application you're building and what type of access control model you're trying to build, if it's role-based or relationship-based or attribute-based, you'll have different preferences between these solutions. For the rest of the show, I'm going to focus on Open Policy Agent, OPAL, and also maybe talk a bit how this can connect to Google Zanzibar and other implementations down the road. If you want to look at the implementations of Google Zanzibar, I've listed a couple here, including Offset and Ori, which are both open source. So let's look slightly deeper at OPA, at Open Policy Agent. So in the end of the day, we have a microservice that is managed by OPA. OPA can be a sidecar to that microservice, or it can run as a separate cluster and be a scaled out microservice on its own. But at the end of the day, we have a service which will be sending queries to OPA to ask it to essentially implement its authorization mechanics. We load both policies in a language called Rego, which you can see an example for here, and data in JSON into OPA. Once OPA has both the data and the policies, we can send queries to it and answer things like, is this user allowed to use this feature? OPA will use a Rego code and check across the data for the user list, for example. The idea with OPA is essentially a glorified memcache. So we load all the data into OPA so it can answer those questions quickly, which connects to what I mentioned before about low network latency and high performance. By separating our code into a specific language and into a specific mindset on authorization, we're decoupling it from the primary application logic, and we achieve the most important principle of decoupling policy and code. OPA is mostly used today for access control and authorization for Kubernetes, i.e., which microservice is allowed to talk to which microservice. But more and more people are taking OPA into other layers, and we can also take OPA to the application layer. One of the biggest challenges there is keeping OPA up to date, because we need to load data and policies to it, and those policies can change. For example, we create new roles or we create new rules on who can do what, and we want that to propagate as quickly as possible. And obviously the data itself can change. The user list can change. A new user subscribes and joins in, or swipes a credit card and joins in. We want them to be able to get the service immediately and not the next time we deploy. So there's a challenge around keeping OPA up to date with that data that we need to constantly be loading into it. To address that, there's another open source project called OPAL, which essentially makes OPA event-driven or real-time. OPAL stands for Open Policy Administration Layer, because it administrates updates for OPA. You can find it, by the way, at opal.ac and here on GitHub. I'm one of the contributors to this open source project, so I might be slightly biased, but I really think it's the best way to take OPA to the application layer. OPAL is server client based. So we have the OPAL server, which we can connect our Git repository to. This enables us to be GitOps driven. And it creates a WebSocket pub/sub channel for multiple OPAL clients that can subscribe to updates. They subscribe to updates through topics. And every time we push a new policy or load more data, we trigger an event with the OPAL server, and it kind of rains down into the multiple OPAL clients, which then go fetch the data and load it directly into the OPA agent. So essentially, OPAL runs in the background, connects to different data sources and policy sources, and keeps the different OPA instances that we have up to date. So they will always be able to answer authorization queries correctly when they come from the different services of the application. Next step after that is to kind of wrap everything in a bow, build the interfaces on top. One good tip that I can give you there is to build your code that uses the authorization microservices in a resource-based fashion. Essentially breaking apart your application into different resources and actions, and mapping those into enforcement points, and in those enforcement points, creating links into the authorization layer. So once you map your code into resources and actions, it's really easy to kind of bridge between your classic application logic and your authorization logic in a way that doesn't bundle them back again. Good approach there is often when you're working with something like REST or GraphQL, the routes that you have there are probably already translating very well into resources and actions. You just need to kind of tidy them up a bit. Other challenges that are here that I'm not going to dive into, but I want you to be aware when you're working on our product is, for example, syncing the front end with the front end experience with your authorization. So up till now, we were mostly talking about the backend. The backend receives a request from the user, decides if to allow it to pass or not using the authorization layer. In the backend, we want to shut the door very dramatically if the user is not allowed to do something. But what about in the front end? We don't want exceptions or errors flying all the time. Even more, we can say if a user is not supposed to be able to complete an action by the authorization layer, maybe we don't want to show them that possibility in advance. If they can't pass through the door, maybe they shouldn't see the door. If they can't delete an object, maybe the delete button shouldn't be there. So there's that challenge. There's another open source project that we'll be releasing soon around OPAL that will touch on that. But you can obviously solve it on your own. But the most important thing here is that you should probably be aware of that. And lastly, we want to build different interfaces, as we mentioned before. So we have that authorization layer. We want to build UI components that we can bake both into our back office and into our customer-facing experiences. So we need to think both on how we want to manage our authorization layer. So there are experiences that we want to bake there, and also what we want to enable our end customers to do within kind of a delegated space. As I mentioned before, things like should they be able to view their own audit logs? Should they be able to add users on their own? Should they be able to create roles on their own? Should they be able to create approval flows? For example, someone comes in, they want to approve them dynamically through the application itself. All of these are classic experiences that you've seen in other products, and you are more than likely to see in your own. So planning in advance to be able to build them on top of the authorization layer that we mentioned before can save a lot of pain. Lastly, as we're coming to the end of our time, and I want to leave some room for questions, just a tidbit about what we'll be probably seeing in the future, the kind of hybrid approach. So I mentioned that there are two camps. We have policy agents on one hand, code-based, and we have Google Zanzibar implementation, graph-based on the other side. They both have pros and cons. And those pros and cons are essentially complementary. We can have them work together. So we'll probably be seeing something like a central brain, a graph-based brain that manages the main relationships, and that service would be kind of not distributed. It won't be kind of as a sidecar for each service, but it will be kind of a main one. And we'll have code agents at the edge querying or using data that comes from that central brain. And all of that will be connected with a real-time event-driven link, something like OPAL or similar. I hope you enjoyed the talk so far. And if there are any questions, I'd be happy to answer them.